So explain weathering and mass wasting and describe their geomorphic significance. Weathering, disintegration or alteration of rocks in its natural or original position at or near the Earth's surface through physical, chemical and biological processes induced or modified by wind, water and climate. During the weathering process, the translocation of disintegrated or altered material occurs within the immediate victims of the rock exposure, but the rock mass remains inside. Weathering is distinguished from, so you can see mud flow, earth flow, and solifluction, land slide, slump, rockfall, creep. Erosion by the fact that the latter usually includes the transportation and disintegration or disintegrated rocks and soil away from the site of degradation. A broader application of erosion, however, includes weathering as a component of the general denudation of all landforms along with wind action and fluvial, marine and glacial process. The occurrence of weathering at or near the Earth's surface also distinguishes it from the physical and chemical alteration of rocks through metamorphism, which usually takes place deep into the crust at much higher temperature. Weathering involves physical, chemical and biological processes acting separately or more often together to achieve the distinct disintegration and decay of rock material. Physical weathering causes the disintegration of rock by mechanical process and therefore depends on the application of forces. Disintegration involves the breakdown of rocks into the constituent minerals or particles with no decay of any rock forming materials. The principal source of physical weathering are thermal expansion and contraction of rock, pressure released upon rock by erosion of overlying materials, the alternate freezing and thawing the water between rock cracks and fissures within rock, crustal growth within rock, and the growth of plants and living organisms in rock. Rock alteration usually involves chemical weathering, which the mineral composition of the rocks is changed, reorganized, or redistributed. The rock minerals are exposed to solution, carbonation, hydration, and oxidation by circulating waters. These effects on the mineral decomposition are added to the effects of living organisms and plants as nutrient extraction to alter rocks. Several factors control the type of weathering and the rate at which rock weathers. The mineralogical composition of a rock will determine the rate of alteration of disintegration. The texture of the rock will affect the type of weathering that is most likely to occur. Fine-grained rock will usually be more susceptible to chemical alteration, but less susceptible to physical disintegration. The pattern of joints, fractures, and tracers within rocks may provide the avenue for water to penetrate. Thus, shattered and fractured masses are more likely to undergo weathering than a nomothermic structure. Climate will also control the type and rate of weathering by affecting the likelihood of freeze-throw cycle and chemical reactions. Chemical weathering is more likely to occur and to be more effective in humid tropical climates, and disintegration of rock from freeze-thaw cycle is more likely to take place and to be more effective in subarctic climates. Mass movement, also called mass wasting, bulk movements of soils and rock debris down slopes in response to the pull of gravity, or the rapid or gradual sinking of the Earth's ground surface in a predominantly vertical direction. Formerly, the term mass wasting referred to a variety of processes by which large masses of crustal materials are moved by gravity from one place to another. More recently, the term mass movement has been substituted to include mass wasting processes and the sinking of confined areas of the Earth's ground surface. Mass movements on slopes and sinking mass movements are often aided by water, and the significance of both types in the part each plays the alternation of landforms. The types of land mass movements caused by the factors that such as earthquake weathering include the abrupt movement and free fall of loosened blocks of solid rocks known as rockfalls. Several types of almost imperceptible downslope movement of superficial soil particles and rock debris, collectively called creep. The subsurface creep of rock materials known as bulging. The multiplicity of downslope movements of bedrocks and other debris caused by the separation of a slope section along the plane of least resistance of slip surface, collectively called landslides. The separation of a mass along a concave head scrape moving down a curved slip surface and accumulating at the slope's foot known as a slump. The saturation of debris and other materials of rainfall in the upper section of a slope or valley, increasing the weight of the debris and causing the slow downslope movement called an earth flow. A rapidly moving earth flow possessing a higher water content known as mud flow. A fast moving earth flow is the fast moving earth flow is in a mountainous region called a debris flow or avalanche, and a downslope movement of moisture saturated surfacial material known as solifluction, and frozen substratum material occurring in subarctic regions during seasonal periods is known as periods of surface flow.